All right, students, so here's a quick video on right triangle trigonometry. Well, I'm not sure how quick it'll be, but and for all you Star Wars fans, this is Ahsoka Tano. I don't know where I got this from. It's a really cool image, though. But yeah. So let's think back to our similarity unit, right? And trigonometry in general is built off of similarity. So the whole concepts that we learned there are applicable here. So generally in trigonometry, what we'll see like triangle A, B, C, and then the sides opposite those angles are going to be represented by the lowercase letter. So this is like angle A here, and then the side opposite it is going to be referenced as lowercase a. So that just represents the length of this side here. And then same here, this would be lowercase b, and then the hypotenuse here would be lowercase c. Remember, the right angle always points to the hypotenuse. So let's say I dilate this triangle by some scale factor. Yeah, and so I have this triangle here that's just a dilation of ABC. So I have triangle DEF is a dilation of triangle ABC. I don't know what the scale factor is yet. And then what we do remember is with similar figures and with dilations, all the angles stay the same. That's a really important fundamental thing that we remember, so that these angle measures have to be the same. These angles here, so the corresponding angles are all congruent. Very important. And then the next thing that we learned about similar figures is that the sides are proportional, right? Well, that kind of makes sense too, because like if we look at this example here as say like the short leg of the triangle, so this would be represented as like length A here over the hypotenuse, which would be C, that would have to be equal to D over F, right? Because that has to be consistent. That ratio has to be the same. And here's why. Because A over C has to equal D over F. And why? Well, let's say it's just been scaled up by some scale factor of like, I don't know, 2. So if the scale factor is 2, how do we get from length A to length D? Well, I would multiply that by 2, right? And then how do I get from length C to length F? I would also multiply that by 2. So I could multiply this by 2 over 2, and then I would get D over F. Well, 2 over 2, that's just 1, right? So that's the multiplicative identity. Anything times 1 is itself, so that just means it's just A over C. So that just means A over C equals D over F, which is true. Now let's throw some numbers in here. So if we throw some numbers, let's like use our good friend the 3, 4, 5 triangle, and I scale that up by a scale factor of 2, well, then I would have 3 over 5 equals 6 over 10. So that applies, right? 3 times 2 is 6, 5 times 2 is 10. Well, again, 2 over 2, that's just 1. So I can take that away. So that means that 3 over 5 has to be equivalent to 6 over 10. And that's true. If I simplify 6 over 10, then it's 3 over 5. So that is a fundamental part of right triangle trigonometry. So let's take a look at what right triangle trigonometry is. All right, so let's see what trigonometry is all about. So we have our right triangle here, triangle DEF. And so I'm going to mark this as our reference angle. So we just need an angle of reference so we can keep everything straight. So let's call that our reference angle. So if I'm standing right here in the triangle, and this is my reference angle, then this side here is opposite me, right? That's what I'm seeing across from me, so that would be like represented by this lowercase e. So we'll label that the opposite side. And then this is the side that's connected to me. Now I'm connected to both the hypotenuse and the adjacent side, right? But we'll call this the adjacent side because this already has a name. It's called the hypotenuse. Remember, the right angle always points to the hypotenuse. So if I'm standing at this side of the triangle, at this angle, this would be my opposite side. This would be my adjacent side. If I were standing over here, I would have a different point of reference, right? So these two would be flipped around. This would then be my opposite side, and this would be my adjacent side. So this is like our starting point for trigonometry. And then so what we learned is for all right triangles with the same angle measures, aka similar triangles, similar right triangles, the ratios of side lengths will be consistent, right? That's what similarity is all about. If we know this angle measure, we know that the side lengths have to be the same. So for example, the length of the opposite side over the length of the hypotenuse for a given angle measure is always going to be the same. This length over this length. Doesn't matter the size of the triangle. If I dilate this, as long as this angle is the same, then I know that that has to be the same. And same goes for the adjacent side over the hypotenuse or the opposite side over the adjacent side. So that's what we just kind of looked at before in our previous example. So if we know the angle, can we figure out the sides? Yes, and that's what trigonometry is. It's like trig, triangle, measure, metry, measure. It's just measures of triangles. So it sounds kind of scary, but it's actually, it's pretty fun. It's kind of like puzzles. So trigonometric functions, they were created by this guy Hipparchus. I don't know, it was like thousands of years ago in what is now Turkey. And actually, but trigonometry has its roots like all the way back in like ancient times, in ancient China, ancient India, in Egypt. There's evidence that they used trigonometry to build the pyramids. So what Hipparchus did, though, he created these three functions, and what they are is they just represent ratios of side lengths. So he just sat there and he said, all right, so for a 30-degree angle, doesn't matter the size of the triangle, if it's 30 degrees, I know that the ratio of the opposites over the hypotenuse, that ratio is going to be the same. And so he figured out all of the ratios of all the different possibilities of triangles and wrote them down. And so what it is sine, and you'll see it on your calculator actually. So the sine of angle E, and it's a function, so the input would be the measure of this angle, is the length of the opposite side over the length of the hypotenuse. Cosine, abbreviated as COS, of angle E is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. So if I'm standing here, the length of this side over the length of this side, and the length of this side over the length of this side, are basically creating these trig functions. So like if I input this angle measure, it's going to give me a certain ratio of side lengths. If I input the angle measure for cosine, it's going to give me, this ratio of side lengths. So that's all trig is. And so we can use this to find missing sides. So here, like angle E, side length E over side length F is the sine of E. Side length D over the side length F is the cosine of E. And the tangent of E is side length E over side length D. So let's look at some specific example. So in triangle VWX, the measure of angle X is 90 degrees, Vx equals 35, XW equals 12, WV is 37. What is the value of the cosine of angle W to the nearest hundredth? So this is a delta math question. So let's draw the diagram. Please draw the diagrams. And so I know X is 90, so I'm going to go ahead and label that as my right angle. And then I know XW is 12, and Vx is 35, and WV is 37. So I can use Hipparchus's trig functions, and an easy way to remember them is an acronym known as SOHCAHTOA. And so what that means is the sine of the angle. And so angle W is our reference angle in this problem. What is the cosine of angle W? So the sine of angle W is the length of the opposite side over the length of the hypotenuse. So if here, this is my reference angle, it would be this over this. And then the cosine is the adjacent side over the hypotenuse. The tangent of W is the opposite side over the adjacent side. I know this sounds a little weird right now. It's the first time a lot of you have seen it, but you'll get used to it. So if I'm standing here at angle W, here's my opposite side, here's my adjacent side, and here's my hypotenuse. So if I'm looking for the cosine of W, the cosine of W is just the ratio of sides, the adjacent side, so the connected side, over the hypotenuse. So it's just the length of 12 over the length of 37. So it doesn't matter, like if I scale this triangle up or make it smaller, it's always going to be some scaled up version of 12 over 37 or scaled down version. So what is 12 over 37? I've plugged that in my calculator. It's just approximately 0.32. So it's just saying that, for example, the hypotenuse is about 1/3 the length of the adjacent side. Cool. So that is trigonometry in a nutshell. And what we're going to do in the next video is we're going to look at some more detailed problems, how you actually find the length of a missing side, or how do you find a missing angle. So right now, that's all we have. Hope this helps, and please let me know if you have any questions. Thanks for watching.